Hi, my name is Amy Dahlberg, and my project topic is intrusion detection systems. So, intrusion detection systems are used for software and network based traffic, and they look and they see any activities that are potentially malicious, and they alert the users of that system. So, there are two types that are typically used. The anomaly-based method has the system looking at incoming activity, and it compares it to a profile that they have compiled that is built up of their normal everyday activities. So it will look at the incoming activity and see if it is part of the normal profile, and if not, it will send an alert. This, however, creates many false alerts. The signature-based method consists of a database of signatures that are linked to software or different events. And if the event matches up with something in the database, then no alert is sent. Or if it is a known malicious activity signature, then that is sent as an alert. However, if the attack or the normal activity is not contained in the database, then it has a lot of potential for missing attacks or sending false alerts. So the blockchain can be used with the system efficiently because collaborative intrusion detections are usually used, which contain many different nodes. And so the blockchain integrates with that and very smoothly, and it allows the privacy and security that comes with blockchain and the trust to be brought into intrusion detection systems. And then deep learning is basically a subset of artificial intelligence, and it allows systems to learn from past activity or from data sets with the goal is to have minimal human interaction. So some security and research challenges in this system. When you use the blockchain, there are many potential different attacks, but the most dangerous for this system, I would say, is the 51% attack, because if people with malicious intent got control of the majority of the nodes, then it could be sending attacks, and it could get the system to trust that an attack is not malicious without alerting anyone about it. So this would let attackers get away with their attacks before anyone noticed. So as I said, false alerts are a problem because they, anything that, for instance, in anomaly-based detection, anything that is not considered normal will be sent as an alert. So this generates a lot of alerts that have nothing to do with attacks. And then there are some attacks that go unnoticed, such as in signature-based detection, because if this attack was not included as a signature, then it could go unnoticed in the node and go unreported. One of the future potential research challenges is supervised versus unsupervised deep learning. So deep learning can, basically it's to facilitate making the system itself decide what should or should not be considered malicious. And usually, so with supervised, it is trained on data sets that have labels. And then unsupervised would be trained on data sets with no labels, where the system or where deep learning has to analyze and decide and put their own labels on it and put them into their own categories. So ideally, you want to eventually not have to train the data with labels, but so that's a big area of potential future research. So the two main works that I used the systems proposed in these, and then combined some elements as my sort of contribution. So the first one dealt with an intrusion detection system that would integrate deep learning and blockchain. So, as you know, blockchain provides more security. So when the intrusion detection system is sharing all this different information between all these different nodes, it's less secure. So then the blockchain can step in with its cryptography and its consensus mechanisms and distributed ledger, and sort of provide the security and privacy that it needs. Deep learning, as I said, can facilitate the categorizing of activities. And this system used anomaly-based detection. In the second paper, it was a signature-based intrusion detection method that also integrated blockchain. And then for signature-based detection, so they proposed to develop a database and create this database using blockchain. So the distributed ledger of blockchain would be the signature-based database. So that way, all of the nodes had the signature database in real time, and they could all develop it. And since it's immutable, no one could maliciously go in there and try to change what signatures should or shouldn't be trusted. So I propose that if you use a hybrid of anomaly-based and signature-based methods, then it could minimize or boost the accuracy of the system in alerting users to potential threats. Because with the anomaly-based, it has issues with false alerts, but those should be minimized through deep learning and the blockchain. And then the signature-based method has issues with letting attacks go unnoticed. And so these both combined have the potential to minimize false alerts or unnoticed attacks. So if you take that hybrid method and then you integrate it with blockchain and deep learning, as I said, it should so deep learning should help anomaly-based systems decide what should be considered an attack on top of already having the normal profile. So hopefully that would minimize the amount of times that the system flags an activity that might not be harmful. And then with and through the distributed ledger, so all of these things should boost the efficiency and accuracy of the system, and while minimizing security and privacy threats. And I also propose that you could, so these two papers that I worked off of, they mostly talked about the Internet of Things in this system in the Internet of Things. So I propose that since blockchain is being so widely applied to different industries and systems and such, this system would fit nicely in other applications like healthcare and cryptocurrency and such. And because many systems would also benefit from intrusion detection systems, especially given how many attacks are happening currently. So just to recap, the consensus mechanism can help with privacy and security. So a big issue with implementing a collaborative intrusion detection system was that the different nodes didn't want to share data and trust each other. And with blockchain, it can do that without having an intermediary. And the distributed ledger, so since it's immutable, no one can change the data in it. And so both of these things, this keeps data more private, maintains trust, maintains integrity, and then keeps the system overall more secure. And then false alerts hopefully would be minimized through deep learning and the blockchain because of the distributed ledger, with all the signature, with all the signatures being easily accessed through the distributed ledger. Hopefully less false alerts could be sent up and less attacks would go undetected because the system had access to all of those in real time, and each node had access to them and could add to them to build on the database. So this is just a basic overview, like a general sketch of what the system might look like. So there's host-based systems, which is like software on a computer. And there's network-based systems where it's looking at all of the traffic coming in and everything. And so these two are used, can be used like in conjunction. And then, so both of these could utilize deep learning, and all their data from this could be sent through deep learning, and that could facilitate the system looking for anomalies. And then, so that would go through the intrusion detection system, which utilizes the blockchain. And then it could be used hopefully by a hybrid of the anomaly-based method and the signature-based method. Just a closer look of the anomaly-based method briefly, is that it looks at the normal profile that people who use the system generated. It looks at the normal activities that are enclosed in there, and then it monitors the activities that are coming in and happening in real time, and it compares the two, and anything that is not found in the normal profile, it sends out an alert. And then the signature-based method, it has a database, which in this case would be the distributed ledger. It contains many different signatures of activities, and then it also monitors the current incoming activities, and it also compares the two. And then if there is an activity that is not trusted by the nodes and not shown in the distributed ledger, then it sends out an alert. So that is the end. I'll leave my references in the description on YouTube.